everyone. I'm going to run through introducing trigonometry for tomorrow's Webex lesson. So let's go ahead and get started. And when I say calculator is needed, yeah, you're going to want to have something handy, whether it's going to be on your phone or on your PC or something like that. So let's go ahead and get started. And again, this is an abbreviated lesson, even though it'll go a little bit longer than my short couple of example lessons. First, we're going to look at the terminology that we're going to be using, and we want to get pretty good at this. So what I have here is a right triangle. In a right triangle, we have a 90-degree angle and two acute angles that we don't know the measure of, acute being less than 90 degrees. This could be 50, that could be 40, so on. So we're going to have what is called a reference angle, and our reference angle is going to be called theta in our examples. It could be other things in other courses, but we'll just go ahead and use theta. It's one of the more popular ones to use in mathematics. So theta right here is this angle A, and very often in geometry problems you're going to say angle A, angle C, angle B, so on. So with this being my reference angle, opposite that angle is this side CB right here. This is opposite. Adjacent, which means touching, is going to be right next to it. Hypotenuse is always the hypotenuse. This is never going to be different. So if my reference angle came over here to angle C, now this would be opposite and this would be adjacent. This is an incredibly important definition that we're talking about here. Opposite, we're going just straight across. Opposite, and adjacent, we are touching. So huge definitions. With that, we can create some ratios. Now, I'm not going to get into history. If we were in classroom, I would be going through the history of this, how they came about all this, and the importance of this in mathematics. And I may talk about that in a separate video. But we're here for the meat and potatoes of the lesson. So given angle theta, which is angle C here, we have opposite, adjacent, and hypotenuse. Our first trig ratio that we're going to have memorized is called sine. It's actually S-I-N-E, but we abbreviate it with 3 letters. And this is a function, just like f of x is a function. We have an input of an angle. So this angle, whether it's 35, 45, whatever degrees it is our input, and out will come a ratio of opposite over hypotenuse. Our cosine, which translates to the complement of sine, is adjacent over hypotenuse. And tangent, one of the more important inventions in all of mathematics, is opposite over adjacent. My mentor teacher, when I first started teaching, taught me this SOHCAHTOA thing. I never actually heard of it until I started becoming a teacher, but it's actually pretty good. And she has actually meanings for these words, sumo hippie, so on and so on. It's kind of humorous, I would tell you in the classroom, but I don't think I will online. You can look that up or just simply memorize this. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So what we're going to do is we're going to write the ratios. Now, trigonometry is based on angle-angle similarity, and so we can dilate these things, and it's all going to boil down to the same ratio. So given this triangle ABC, where we have one side is 4, the hypotenuse 5, if we're missing a side, we're simply going to use the Pythagorean theorem, a squared plus b squared equals c squared. Well, this is a 3, 4, 5 triple, so that makes that easy. So this is my input to my function. This is my function. This is my input to my function. No, we don't have weekly warm-ups. All right. So what we're going to do is we're going to look at angle A, that's my reference angle, and do opposite over hypotenuse, 4 over 5. I don't even have her in my class. Okay, so I have tangent of of angle A. Well, let's do cosine of A, and that's going to be adjacent over hypotenuse. That's going to be 3 over 5. Tangent is opposite over adjacent, 4 over 3. And look what happened. Our reference angle changed. Our reference angle is now B. So B is now my reference angle. So when I talk about sine of B, that's going to be opposite over hypotenuse. Cosine of B is adjacent over hypotenuse. and tangent is going to be opposite over adjacent. So those are how we find our basic trig ratios, and I'm going to give you a maze practicing all for that stuff. Okay. Now I like to give my students trig tables, and we go through this in the classroom. And this is again if I have a right triangle and I have a theta. Now remember, angle, angle, angle doesn't prove congruency, so I can have a 35-degree angle here. Actually, let's make that 25-degree, and I can have a 25-degree here, but I can have bigger sides. I can have this dilated. But when I do the opposite over hypotenuse, that fraction is going to boil down to the same decimal fraction. So I'm going to try something here. Now my program sometimes acts up, but I'm going to put in, and I already did a video for you to look at on how to use the calculator. So let's do sine of 13 right here. So I'm going to do sine of 13 and hit enter, and I get 0.224, which is pretty close to what this is right here. Okay. Yep, it doesn't work, so I'm going to put this on pause. So for some reason, when I actually activate my calculator, my pen freezes up for some reason. So that's a little annoying. I had to log out and log back in on my program. So I'm going to try and avoid using the calculator as much as possible so I don't pause as much. So here we have inverse tables. We're going backwards. Say we're going to take, say, sine of 49 degrees, which is right here, and I put that in sine 49, I should get 0.75. But if I don't know the angle, this is unknown, but I know the ratio, I can actually go sine -1 of 0.92718, and I'm going to get 49 degrees. Oops, that one's going to be 69 degrees. Okay, 67.9 degrees, or 68 degrees. All right. So that's how that would work. Now refer to my video on the calculator, because if I go and hit the buttons over here, it's going to freeze up this program, and it takes about 3 minutes to get it going again. So I'm going to go ahead and proceed. So when we find this, I'm going to go ahead and put these in the calculator. Go ahead and do this first on your calculator. Plug these in. Tell me what you get. And let's see if we find out what we have. Then I'm going to plug this one in. And I won't be able to write these in when I put them in the calculator, so I'll be looking in the screen over here. So I'm going to go ahead and do it now. Sine of 25. Enter. You should get 423. So cosine of 25, the complement of sine, 0.906, and cosine of 65. Now look what's going to happen here. This is pretty cool. I get 0.42 sine, 423. Well, the cosine is literally the complement of sine. These are called cofunctions. Now, because I can't write on here, see, it doesn't write anymore, I'm going to go ahead and do the inverse. Again, refer to my other video on how to use the calculator. But I'm going to come over here and hit Shift, Sine, 0.875, Enter, and I get about 61 degrees. Alrighty, so again, I got to pause. Alrighty, so picking up, just real quick, I had to go in and play with it again. So all my calculator calculations are pre-done. Just try and follow along. You can pause the video as you see fit. So let's go ahead and get some more practice in. I thought I did this. Oh, we're going to skip it. Okay. So let's go ahead and solve some right triangles here. So let's get started. So the first thing you're going to do is you're going to determine your reference angle. We'll call that 54. I could find its complement and put it right here and use that one instead. It doesn't matter. But I'm a little bit lazy. I'm just going to go ahead and use 54. And I'm solving for this side right here. That side is opposite. That's adjacent. Your SOHCAHTOA says we're going to use tan. So we're going to do tan of my function, of my angle, tan of 54, is equal to opposite, we don't know what that is, over 10. A little bit of algebra, we're going to multiply by 10 on both sides. So we multiply by 10 here and 10 here. So we're going to cancel that out. And we're going to put in 10 tangent 54 in the calculator. And that's exactly what I did right here. Again, I can't touch my calculator or it freezes up. That's real annoying. So we're going to have our tangent ratio. Okay, and put it in the calculator, we get about 13.8. Okay, 13.8. All right. So this is actually my acute angles. So this should have been larger because that's my biggest angle. This is my smaller one. So, you know, that's just 36 degrees here. And I would have got the same thing if I used 36 degrees. So here we're going to solve for x and y. Here's my reference angle. This is opposite. That's hypotenuse. Opposite over hypotenuse is going to be my sine. So sine of 32 is equal to x over 18. Multiplied by 18 on both sides. Now I'm not sure on day one we give you examples where we give problems where the algebra is a little more trickier. That cancels out. So 18 sine of 32. And I plug that in the calculator, and this is what I get, about 9.5. To find my y, that's adjacent, so that's going to be cosine of 32. I could have done a squared plus b squared equals c squared as well, since I already found two sides, is equal to y over 18. Multiplied by 18 on both sides, 18 cosine of 32 is equal to y, and I put that in the calculator and I get that. Go ahead and practice that now. You can put this on pause. Okay, the next one. So here I have, I'm going to solve for x, and again it doesn't matter which one I use. I went ahead and used 49, so this is going to be adjacent. So it's going to be cosine of 49 is equal to x over 9 multiplied by 9 on both sides. Now on day one we tend to give you easy ones, but sometimes every now and then we're going to give you the hypotenuse and expect you to find the angle. Say that's going to be 7. And what I have here is I'm going to have sine of 35 is equal to 7 over x. Well, I just multiply by x on both sides and then divide by sine of 35 on both sides. I have 7 over sine of 35. Basically, these just swap places. Now, I'm not going to put that in the calculator. Moving on, if we're going to solve for an angle, we've got to use the inverse. That's what we practice that for. That's going to be opposite over adjacent, so that's going to be tangent. So tangent of x is equal to 6 over 8. We're looking for this here, so we're going backwards on the trig ratio. I could put 6 over 8 in the calculator, come up with a decimal. Don't need to, so I'm just going to tan inverse of 6 over 8 is equal to my angle. Plug that in, and my angle is about 37 degrees. Okay, 37 degrees. So that's pretty much it. We'll do one more example of this. So I have my reference angle is n, opposite, hypotenuse, that is sine, so sine of angle n is equal to 25 over 31. Inverse it, put that in the calculator, and I get about 54 degrees. Alrighty, I think that is it. Just some more practice. This is all this is. So I'm going to leave these in my notes. If you practice this, tangent of x is equal to 0.638. You just put the inverse in. Make sure you practice it and get the same answers that I get right here. Okay? Okie dokie. I am going to let you go, and that's just more examples. Practice this one on your own. See if you get this answer here. Okay? I'm going to let you go, get this posted to YouTube and Webex, and have a live session on Monday. Okay, see ya.